Welcome back to the channel, guys. So, without wasting any time, let's move on to the next question. Up till now, we have done find duplicate in an array of n plus one integers. So, next question is merge two sorted arrays without using extra space. Very interesting problem. If you can see, sorry, if you can observe, it is also mentioned as hard problem. So, we'll get a point appraise of 8. Okay. So, let's see what does the problem says. It says that given two sorted arrays, we have to mention sorted also here. Okay, given two sorted arrays arr1 and arr2 of sizes n and m. Okay, in non-decreasing order. Sorted means that only. Merge them in sorted order without using any extra space. Modify arr1 so that it contains the first n elements, and modify arr2 so that it contains the last m elements. You see it is given here, the time complexity is O of n plus m log of n plus m of 1. Okay, let's see how we have to proceed. Let me open the node area. Okay. So it says we have array 1, array 2. Both of them are sorted. Its size is n. Its size is n. Now, what we have to do, suppose AR1 is 1, 2. Let me take the example given to us only, right? 0, it is given 1357, 1, 3, 5, 7, and 02689. 02689. It is saying that we have to convert AR1 and AR2 such that they appear sorted. Like, what if I take a merged array? Like, let me take an array which consists elements of all of these. That is 1, 3, 5, 7, 0, 2, 6, 8, 9. This is the array containing all the elements mentioned in array 1 and array 2. Alright. What if I sort it? After sorting, it becomes 0, 1, 2, 3, 5, 6, 7, 8, 9. You can check it is a sorted order only. It is saying that that like n here is 4, the size of the array is 4 here, and m here is 5, size of array is 5. It is saying that we have to convert array 1 and array 2 such that array 1 after transformation contains the first four element of this order 0, 1, 2, 3, and array 2 contains this one 5, 6, 7, 8, 9. Okay, how can we do it? The first foremost, the most easiest approach is take an array of size n plus m, form, insert all elements, after that sort it, and then fill the original array. Correct? So time complexity of it would be O of n plus m to insert n plus m log of n plus m, correct? Here. To sort, okay. And to fill, again n plus m. So in total it would be O of n plus m log of n plus m. Okay. So I think it is matching the expected time complexity. But what is the space complexity here? Space complexity is also O of n plus m because we have to use an extra array to insert the elements. I hope I am clear. What is next approach? Next approach can be such, like we were given 0, 1, 3, 7, 5, 6, 8, 9. Like this is the array. Okay, comma 10. What I do is I take an n plus m length array. Okay, so there was 4, there was 5. So I have to use n 9 indexes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I say I keep a pointer here. I I keep a pointer here. J. What I do is I just start putting elements like in this order, that if AR1I is less than equals to ARR2J, insert ith element, then I plus plus, else insert jth element, j plus plus. So what I'm doing is like compare 0 is less than 5. So put 0 here, move I to the 1 element. Now 1 is less than 6. Now 1 is less than 5. So write 1 here, move I here. Now 3 is also less than 5. So move 3 here, I here. Now 7 is greater than 5. So move 5 here. Okay. And then j here at 6th. Now 7 is greater than 6, so move 6 here, j forward. Now 7 is less than it, move 7 here. I goes out of the bounds, and when I goes out of the bounds, we put the remaining elements in the subsequent position. That is 8, 9, 10. Now if you see the array after merging is sorted. Sorry for the string used. It is sorted. So we are saving the sorting time we used above. Needs not to be done. So what will be the time complexity? N plus M to insert plus N plus M to fill. But the problem here arises the same space complexity is again O of N plus M here. Because we have to use another array to insert. Okay. So how do we solve the space complexity problem? It is very beautiful approach. And it can be used in the further questions you solve while continuing your practice for data structures, algorithms for placements, or any other reason. I say that suppose you were given array, take the example one only. 1357 02689 1357 02689. Okay. I say for the first array, second array. Okay, I say keep an I pointer here and keep an J pointer here. Okay. I say, see, the sorted order after sorting the array should have looked like array one should have looked like 0, 1, 2, 3, and array 2 should have looked like 3, 5, 7, 3, 5, 6, 7, 8, 9. Correct? Or have that? Oh, sorry, it is will 5, 6, 8, 7, 8, 9. It should have looked like this. Correct? So now if 7 is greater than 0, if 7 is greater than 0, shouldn't 7 be in this array and 0 should have been this in this array? This example was supported 7 is in this array, 0 in this array. Because if 7 is in greater than 0, then 0 should have come prior to 7. And if 0 should have come prior to 7, and 7 is in this array, so 0 should have been in this array. So because 0 is in this array, 7 is in another array, correct? So let me do that. So what I do it, I swap I and jth element, okay? So the array becomes 1, 3, 5, 0, and here it becomes 7, 2, 6, 8, 9. Now what should I do? I should decrement the ith pointer, increment the jth pointer. Okay. I see that 5 is also greater than 2. So 2 should have been in this array and 5 should have been in this array. I do that. I take 2 here, I bring 5 here, I move j here, and move I here. Now 3 is less than 6. Now we have arrived at the position that array I is less than the array j. Now tell me yourself, if 3 is less than 6, so 3 should have been in this position only, correct? Now if 3 is less than 6, is this element also guaranteed that it will be less than 6? Now because we have been given that the arrays are sorted initially, so now if 3 is greater less than 6, so 1 is also less than 6, correct? And now 1, if 3 is less than 6, these two elements are less than this element, then these two elements have to be less than the remaining elements also, right? So what do we get? We get after we arrived at the condition where this happens, the array elements are correct. Not in the correct order, but in correct positions. Like they are in the array which they should have belonged to. So after that, what we have got, array 1 is looking like 1, 3, 2, 0, and array 2 is looking like 7, 5, 6, 8, 9. Am I correct? Yes. But now the problem is not yet solved. We have to return them in sorted order. So what do? I sort them individually. Let's analyze this. So what is the time complexity now? Time complexity now is n plus m to swap, etc. Okay, no problem. Then n plus n log n plus m log m to sort. But the main problem was space complexity. Now, if you are able to observe, we have not used any n extra array. We have used variables that for sure. So the space complexity is over one. Our criteria are matched, and we have got a final algorithm that we should have used. Let me read the pseudocode for you. What I said: I equals to n minus one, j equals to zero, while I is greater than zero, and j is less than n. Do one thing: if array of I is greater than equals to array of j, swap, else, and swap then I minus minus j plus plus, okay, else break. Then after that, after the while loop, sort array 1 and sort array 2, and then the final step, that is return. Okay, let me code it down for you real fast. Our pseudocode said that int I equals to n minus 1, int j equals to 0, point to the first element of second array. Now run a loop while I is greater than equals to 0 and j is less than m. If array 1 of I is greater than equals to array 2 of j, you can also do swap. I'm using the temporary variable method. Long, oh sorry, typing mistake. Long temp equals to array 1 of I. Array 1 of I becomes array 2 of j, and array 2 of j becomes temp. Alright. After that, I will decrement, j will increment. Else, if the condition is not executed, just break and then sort both the arrays individually. It will be ham here. Final step, the most important step, return. Let's see if we have not committed any typing mistake. No, we have not committed any typing mistake. Let's hope that submit also works. Yes, it's working. Thank you for watching the video. Please don't forget to like and subscribe. Also, we will meet in the next video solving the DSA love sheet forward. Okay, thank you. Bye.